Scientific measurement, notation, and significant figures. Yung learning targets with this lesson is you can state the number of significant figures in a number and why they are significant, and also you need to calculate problems and have the correct number of significant figures in the answer. You can easily read the temperature on this thermometer on the nearest degree. Ito yung mga value or ito yung significant ng significant figures and scientific notation. You can also estimate the temperature to about the nearest tenth of a degree by noting the closeness, kung saan yung pinakamalapit niya na numbers of the liquid inside the calibration, and suppose you estimate that the temperature lies between 22 degrees Celsius and 23 degrees Celsius at 22.9 degrees Celsius. So halimbawa, meron tayong temperature na 22.9 degrees Celsius, it can be 22 or 23. Depende kung paano mo siya i-estimate, rounding off or rounding numbers to the highest degree, or yung next possible number, or yung lower possible number naman niya. This estimated number, 22.9 degrees Celsius, has 3 digits. So, the first two digits, 20 and 2, are known with certainty. So, ito na yung kita mo kaagad, whole number kasi siya. While the rightmost digit, yung number 9 or 0.9, it has been estimated and involves some uncertainty. Hindi ka sure kung 0.89 yan or 0.91 yan. Kaya sinabi natin na estimated lang siya at meron siyang uncertainty or hindi gaano sigurado. These reported digits all convey useful information and are called significant figures. By definition, the significant figures in a measurement include all the digits that are known. Yung kita or alam ko mo kaagad. So, significant figures yon. Plus a last digit that is estimated. Kasali naman yung last digit na na-estimate natin. Okay? So, measurement must always be reported to the correct number of significant figures because calculated answers cannot be more precise. When you say precise, sakto, no? Than measured data. So, halimbawa, meron tayong door. So, yung the width of the door can be expressed as, say for instance, yung lapad niya ay 0.8 meter. Now, for sa meter stick natin, nakalagay 0.8, no? Because 0 is known and 0.8 is estimated. Wala pa siyang isang metro kaya 0.8 siya. Wherein 0.77 meter for meter stick B, doon naman sa pangalawang meter stick, nakuha siya or nakita siya na 0.77 siya. Yung 0.7 is the known value and the 0.07 is the estimated kasi hindi na nakikita ng naked eye. Diba? Masyado ng detailed, masyado yung 0.77. However, on the third meter stick, yung meter stick C, yung reading naman niya ay 0.772 meters. So, because 0.77 is known, yun yung kitang-kita, and 0. Or yung 0.002, ako lang yan, 0.002 is estimated value na lang ng meter stick C. Okay. In determining significant figures in measurement, to determine whether a digit is measured value is significant, you need to apply the following rules. Una, every non-zero digit is significant. So, lahat ng hindi zero, say for instance, 1 to 9, no? Lahat yan significant. So, each of this measurement has 3 significant figures. Say for instance, 24.7, 0.743, apat siya na digit, diba? Kaya lang, ang sabi sa number 1, every non-zero digit is significant. Yung 0 na nasa unahan is leading 0 yon. So, hindi siya kasali, hindi siya significant. On the last example, that is 714 or 714 meters, and all of that digits, 3 digits ay non-zero. So, meaning that those numbers are all significant. Okay? Second, zeros appearing between non-zero, yung mga zero daw na nakikita natin na nasa gitna or in between ng hindi naman zero digits are significant, and these numbers or digits are called sandwich zeros kasi parang nakapalaman siya doon sa mga hindi zero na digits. So each of this measurement has 4 significant figures. Why? Because meron ngang dalawang zero in between 7 and 3. So that is 7,003 meters. Sa second example, that is 40.79 meters. Meron ding isang sandwich zero na nasa gitna ng 4 at saka 79. Also, the last example is 1.503. Meron ding isang sandwich zero. So, lahat ng yan ay kasali siya or binibilang siya as significant figure. Number 3 or rule number 3, trailing zeros follows a non-zero. Yung trailing, ibig sabihin yung kasunod, kasunod na zero follows a non-zero digit are significant only if there is a decimal point. Halimbawa, 500. One significant figure lang yon. Kaya lang kung lalagay natin siya ng 0.00500, yung unang tatlong zero sa unahan, leading zero siya, diba? So, hindi siya included. However, yung nasa dulo, pasok siya kasi trailing zero naman yun. Yung dalawang zero na nasa dulo is trailing zero. Okay? So, kasali siya or binibilang natin siya as significant figure. Including the second example, 0.03040. So, yung zero na nasa dulo, yun yung trailing zero na tinatawag. Also, yung 2.30 times 10 raised to negative 5, meron din siyang isang trailing zero. 4.500 times 10 raised to 12, meron siyang dalawang trailing zeros. At saka yung 100.000, meron siyang limang trailing zeros. Okay? So, yun yung sinasabi ng rule number 3. Okay? So each of this measurement has 4 significant figures, y, find and captured, and trailing zeros. Dito sa unang example, 43.00, meron kasi siyang dalawang non-zero, yung 4 at saka 0. So meron na tayong dalawang significant. Also meron tayong trailing zero na dalawa. Kasi meron decimal, diba? So kasali siya. So 4300, that comprises 4 significant figures. For the next example, 1.010, meron tayong isang trailing zero, di ba? And then meron namang nasa gitna. Meron tayong sandwich zero. And the last one, 9.000, ay may tatlong trailing zero siya. That is included because merong decimal point. Okay? Which digits are significant figures? First, all non-zero digits 1 to 9. The second, sandwich zeros which are between non-zero digits. So, halimbawa, itong example, 1001.000. Yung 1001, meron siyang sandwich zero. At yung 0.0000 ay trailing zero naman siya. Okay? May decimal point kasi. Okay, next. Which zero digits are not significant figures? Yung una or leading zeros before real numbers. Example, 0.000231. So, yung 0.000, yung apat na zero, hindi siya kasali or hindi siya significant figures. Those are leading zeros. Trailing zeros after real numbers, if no decimal, kung wala siyang tuldok, kuwit lang yung nakalagay, is written, halimbawa, 1 million, lahat yun ay hindi siya significant. Okay? Itong 6 na zeros, trailing zeros, pero walang decimal, ay hindi siya significant figures. So, each of this measurement has only 2 significant because yung nasa unahan natin, first example natin, 0.0071 meter or 7.1 times 10 raised to negative 3 meter, meron siyang leading zeros na tatlo, so hindi siya kasali. And for the second example, 0.42 or 4.2 times 10 raised to negative 1. So, ito yung scientific notation niya. No? Yung nasa left side is the significant figures and on the right side is the scientific notation. So, ito ay meron din siyang only 2 significant figures. While on the third example, 0.000099, meron din siyang dalawang significant figures. Sorry. Because of the 5 leading zeros na nasa unahan ng digits na yan. And for the scientific notation, that is 9.9 times 10 raised to negative 5 meter. Ayan. So, ito yung mga sinasabi natin. Hindi siya kasali, no, ng mga leading zeros natin. So, these are leading zeros. All digits are significant using scientific notation. So, dito naman, 7.1, 4.2, 9.9, lahat yan ay significant kasi nandun siya mismo sa scientific notation. The zeros in this measurement are not significant. Halimbawa, 300. Di ba trailing zeros yon kasi sunod naman siya sa non-zero digit pero wala kasi siyang decimal. So therefore, that is only comprises of one significant figure. For the second example, 7,000 meters, only one significant figure pa rin siya because the three trailing zeros, 7,000, yung 000 ay trailing zeros dapat siya. Kung meron siyang decimal place, significant yon. Since wala, so hindi siya kasali and that is only one significant figure. For the last example, 27,210, apat lang yung significant figures because the zero at the end is not considered significant kahit na trailing zero yan because wala siyang decimal point. Okay? So, no captured zeros, nor trailing zeros, no decimal points. Okay, meron pa, unlimited number of significant figures. There are two situations in which numbers have unlimited number of significant figures. Halimbawa, yung sa counting and equivalence. The first involve counting. Example, 23 people in your classroom. So this measurement is counted value. So it has an unlimited number of significant figures. The second situation involves equivalent naman. Yung una, counting or pag nagbibilang tayo, di ba? So like those found within a system of measurement, each of these number has an unlimited number of significant figures. Say for instance, 60 minute or 1 hour or 1,000 centimeter, that is 1 meter. Counting and equivalence do not limit the significant figures in your calculations. So yun yung dalawang situation of unlimited number of significant figures. Then we come now to the rules for significant figures. Rule number one, non-zero digits are always significant. Rule number 2, sandwich zeros. Any zeros between two significant digits are significant. And the last, trailing zeros are significant if there is a decimal point. Meron pa, yung additional na unlimited significant figures or tinatawag natin na counted values and equivalence. Now, suppose that the winner of a 100-meter dash finishes the race in 9.98 seconds. The runner in second place has a time of 10.05 seconds. How many significant figures are in each measurements? Give the rule number 1 to 4. Okay, so there are three significant figure in 9.98 kasi lahat yan ay non-zero digits. Okay, so there are 4 significant figures in 10.05 because of the sandwich. Every non-zero digit is significant and then meron siyang sandwich zeros. Okay, how many significant figures are in each measurement? So give the rule or rules for counting significant figures. So ayan. So in your mind, can you please compute or ilan kaya yung significant figure ng A, B, and C? Okay. So, given the rules, you can answer that. Yung A is 3 significant figures siya because 1, 2, 3 or letter A are all non-zero numbers. Yung letter B ay 5 significant figures kasi lahat yan ay non-zero numbers at saka meron siyang sandwich zero. Yung numbers or letter C naman is 5 significant figures because of the 4 trailing zeros with a decimal. Okay, so that are all or those digits are all significant. Ito naman, how many significant figures are in measurement? So given there's ulit 22, so this is 2, no? Kasi wala naman siyang decimal, wala siyang zero. Yung letter B is 4 because of yung nasa unahan natin na leading zeros, hindi siya kasali. Okay? Paano naman tayo nagra-rounding? So, to round a number, first divide how many significant figures the answer should have, and then round to that many digits counting from the left. So, 4 and below, let it go. 5 and above, give it a show. No, may dagdag. Diba? Ganun tayo mag-round up. So kapag round off its measurement to the number of significant figures shown in parentheses, apat. So, halimbawa, 314.721 meters, i-round off mo siya na dapat meron tayong significant figures na apat. So, anong mangyayari dyan? So, that is 314.7 because 2 is lower than 4. Yung letter B naman ay round off natin siya into two significant figures. Yung tatlong leading zeros ay hindi kasali. So, apat lang dapat yan. Kaya lang gagawin natin siyang i-round off natin siya into two significant figure. So, that is 0.0018. And then, ito namang pangalawa ay 88. Okay, 00. Pwede siya mag-00 sa dulo. Kasi, or 88 lang, pwede naman, ano? Kasi yung 00 is the trailing zeros na hindi naman siya kasali sa significant figures and also, meron siyang, wala kasi siyang decimal point. Okay? Rounding measurement. The arrow points to the digit immediately following the last significant digit. So, write your answer using scientific notation. So, yung 2 dyan is less than 5. So, you do not round up. Ito yung kaninang example, ano? And ito din, 7 ay greater than 5, so nag-round off tayo ng isa. Dito naman, yung 9 ay more than or greater than 5 tayo, so nag-round up naman tayo. Significant figures in calculation. So, a calculated answer cannot be more precise than the least precise measurement from which it was calculated. So, meaning, the calculated value must be rounded to make it consistent with the measurement from which it was calculated based on the number of significant figures. Halimbawa, a die measure 1.8 cm on each side. Its volume is 1.8 cm times 1.8 cm times 1.8 cm, or that is equals to 5.832 cm cube. So this is incorrect because the measurement have tens and the answer is expressed using thousand. So ito yung kung paano tayo mag-calculate ng significant figures. For the other definitions or glossary terms, measurement is a quantitative description that involves or includes both of a number and a unit. The scientific notation is an expression of numbers in the form m times 10 raised to n, where m is equal to or greater than 1 and less than 10, and n or yung exponent n is an integer. Yung integer dyan, pwede siyang negative or positive. Then, accuracy. So, accuracy is the closeness of a measurement to the true value or what is being measured. Ito yung pinakamalapit sa katotohanan or in other term that is accurate. Precise or tama, precision describe the closeness or reproducibility of a set of measurements taken under the same condition. Accepted value, ito naman yung quantity used by general agreement of the scientific community. Experimental value is a quantitative value measured during an experiment. The error is the difference between the accepted value and the experimental value. The percent error is the percent that measured value differs from the accepted value, and the last is significant figure, all the digits that can be known precisely in a measurement plus a last estimated digit. And that's consists of our module number 4.